physical quantity in terms of vectors and scalars. To identify a physical quantity as a vector, some basic things you need to remember. First one is, a vector must have some magnitude, a unit representing that physical quantity, and must have a sense of a specific direction. On the other hand, a scalar can be identified for having only magnitude and unit, and there is no sense of some specific direction. Example of vector quantity includes displacement, another example would be velocity, then acceleration, momentum, force, etc. Example of scalar quantities include distance, speed, mass, energy, work, power, etc. Let's try to find out how we are going to represent a vector quantity. We know it is different than scalar quantities, and we'll see how two vector quantities are added, multiplied, subtracted. But first of all, we'll learn how to represent a vector quantity. A vector quantity is represented by an arrow like this, oriented in some specific direction. The length of this arrow represents the magnitude of that vector, and the arrow points in the direction of the vector. So we have length of this arrow is proportional to the magnitude. The arrow points in the direction of the vector. To represent a variable vector, we must also represent it different from any scalar quantity. That's why, let's suppose this vector is some A vector, and in order to identify this A quantity to be a vector, we put an arrow over it such that it represents a vector quantity which has magnitude equal to arrow of this length, which has magnitude equal to length of this arrow, and it points in the direction of the arrow. Let's try to represent some of the vectors on paper, and we must get used to it. And a few points we have to keep in mind about the proportional representation of the length of the arrow of a vector. Suppose we have to represent a 5 Newton force, and we go on representing a 5 Newton force in this direction, which is given by the direction of the arrow, like this. Then a 10 Newton force in horizontal direction must be represented by arrow pointing in horizontal direction, and its length should be double of length used for the representation of 5 Newton. So it must be really double of that. Don't have to use the scale for doing this. It should look like a double of that. That will do. And suppose I want to represent a 7 Newton force, then it should be greater than 5 Newton and less than 10 Newton for its proportional representation. So I want to represent the 7 Newton force in vertical direction, and its length should be in between 5 Newton and 10 Newton. Something like this. Vertical direction. So that is what we mean by saying the length of the arrow is proportional to the magnitude of the vector. Now let's discuss some conditions for a physical quantity in order to identify it as a vector quantity. There are three such conditions, so we'll write them down. In addition to magnitude and unit, a vector must, point number one, have a specific direction. Point number two, must follow commutative law for addition. That means vector A plus vector B must be equal to vector B plus vector A. And third rule is must follow parallelogram law for vector addition. So in order to be a vector, a quantity must have a magnitude and unit, and three more important conditions. It should have a specific direction. It should follow commutative law for vector addition. That means vector A plus B is equal to vector B plus A, and must follow parallelogram law for addition. Now we'll try to understand what could be the angle between two vectors and how it is defined. Suppose I have two vectors. Vector space like this, and another vector in space like this. And suppose I want to know what is the angle between these two vectors. Let's call this vector B, and let's call this vector A. Now, vector B will remain unchanged if I move this vector anywhere in the space parallel to itself, because its magnitude is not going to change and its direction is still intact. It points in the same direction. So a vector can be moved parallel to itself anywhere in its space and will remain unchanged as long as the length of the arrow and the direction of the arrow is same. So B can be moved anywhere in the space. Same goes with A vector. It can also be moved anywhere in the space and still the vector remains unchanged. So let's come back to the point that what is the angle between A and B in this case. So in order to find the angle between vector A and B, the important point to note is I can move vector B parallel to itself and will try to join the tails of A and B without changing the vector. So I move D, I move B and bring its tail near to the tail of A vector and join them. then obviously my B vector will remain same. This is still my B vector. Now, the angle between A and B in this case is defined as the smaller of the two angles formed by joining tails of A and B. So you can see there are two angles. One angle is this, and the other angle is this. So the angle between vector A and B is defined as the smaller of the two angles. So this is not the angle between A and B. This qualifies as our angle between A and B as defined. So if the angle is theta, then we will say here that angle between A and B, don't forget to put an arrow over A and B because they are vector. So the angle between vector A and B is equal to theta. We can write it here, the definition for angle between two vectors. It is the smaller of the two angles formed by joining tails of the two vectors. Now we'll try to learn how to add two vectors. In order to add two vectors, we have a very special law that is called parallelogram law for adding two vectors. So let's try to understand this law, which will help us to add two vectors. Suppose I have two vectors well defined. Vector A in this direction and another vector B in some other direction, which is also well defined. Suppose this is vector B. Now I want to add this vector, which is vector A. Let's label them. We call this vector A vector, and we call this vector B vector. So they are well defined, so the angle between them is also well defined. You know how to find the angle between two vectors. I have to move B or A parallel to itself and join their tails and pick the smaller of the two angles. Anyway, let's say the angle between them is well known as well because A is well known, B is well known. So angle between them is also known. Now we have to add vector A and B. Let's represent a vector R, which is also known as resultant of A and B, which means nothing but the result of adding A vector with B vector. Suppose I want to know R vector, which is sum of A vector and B vector. This addition is only valid if A and B represent same physical quantity. As you all know, that we can add only those quantities which are similar. Length can be added to length, so displacement can be added to displacement in case of vector. A force cannot be added with a velocity vector. So it is understood that A and B represent same physical quantity. So in order to add A and B and get resultant R vector, we will follow parallelogram law. It states that we have to complete the parallelogram by joining the tails of two vectors as adjacent sides of the parallelogram. So let's try to do that. Move vector A parallel to itself and B parallel to itself and join them at their tails. So let's say that vector is well defined. So our angle theta between the two vectors is this angle. Now, the The parallelogram law states that you have to complete a parallelogram using A and B as adjacent sides. So let's try to do that. So we have made a parallelogram using A and B as adjacent sides. Then this law suggests that this vector, so one of the diagonal of the parallelogram, this vector forms, this diagonal represents the sum of A and B. So you can label this vector R vector is nothing but diagonal of the parallelogram formed by joining tails of A and B as adjacent sides. This is R vector, which is A vector plus B vector as suggested by this law. Our job today is to find the length of this vector because it represents really the sum of A and B. So length of this arrow will represent magnitude of A plus B. And also the direction of this vector with any of the vector A and B. You should know that I can represent a vector A like this, but if I put a mod over it, then it represents magnitude of A. Similarly, if I take B vector, I can represent it like this, and if I put a mod over it, that will represent magnitude of B. That implies modulus of A, this mod A, is equal to length of vector representing A. So the length of this arrow can be said to be mod of A, and length of arrow representing B vector is mod of A. Then length of this diagonal, which represent A vector plus B vector, will be magnitude of R or magnitude of A plus B. So we can say magnitude of R is equal to magnitude of A plus B, and our job today is to find what will be the length of this diagonal given length of A and B. It's a geometrical problem now, and all we have to do is find length of this red line using length of A vector and length of B vector. We can use little construction here. First of all, let's drop a perpendicular from this point and extend A vector to cut this line at, let's say, some point P. And let's call this the end of head of A to Q. Let's call this vertex O. Then you can clearly use geometry here and say that if this angle is theta, the angle between A and B is theta, then because this is parallel to this line, so this angle will also be theta. Let's call this point C point. Now, there are two right angle triangles as you can see here. This will be 90 degree. So we are observing two right angle triangle OCP and QCP. From there we can find the length of this diagonal. Now, given the length of this arrow is modulus of b, we can say length of this line will be equivalent to modulus of b, which also happens to be the hypotenuse of triangle C, Q and P. So, in right angle triangle QCP, which is right angled at P, we can say QP, length of QP will be equal to hypotenuse cos theta. Hypotenuse is mod of B. This can be written as cos theta, because as you know, cos theta will be equal to base by hypotenuse, and base is QP. Then we can cross multiply to get QP equal to hypotenuse cos theta. Similarly, the length of CP can be written as mod of B sin theta. Going further, we can write in right angle triangle OCP, we have hypotenuse is equal to modulus of R. Using Pythagoras theorem, we can say here that OC square is equal to OP square plus CP square. Now, OC square happens to be length of the diagonal, which is can be also represented by modulus of R or modulus of A plus B, so square of that. It's equal to OP square. OP can be written as OQ plus QP whole square, that is for OP, and CP square. Now we can write OQ is equal to modulus of A and QP is equal to, basically QP is here, QP is modulus of B cos theta, modulus of B cos theta, and this is square over that, plus CP square. CP square can be written as modulus of B sin theta and square of that. If you go on manipulating this, and this can be written as modulus of R or modulus of A plus B square is equal to modulus of A square plus modulus of B cos theta square of that, so modulus of B square cos square theta, plus 2 into modulus of A modulus of B and then cos theta. That is for this term, mod of A plus B cos theta. Then there is also mod of B sin square theta whole square, so it will become modulus of B square and then sin square theta. So if you can see here, if you plug this term and this term, then mod of B square will be taken outside and there will be term inside which will be cos square theta plus sin square theta, which is 1. So we can write the result as there will be modulus of A square, then there will be a modulus of B square, because of this and this term added together will give you modulus of B square, and is left is twice into modulus of A, modulus of B, and cos theta, and theta happens to be the angle between A and B. So we can write this result that modulus of R is equal to under root of modulus of A square plus modulus of B square plus twice into modulus of A, modulus of B cos theta. This is square root of. Pull it down. And this can be treated as our formula for finding modulus of A plus B. So let's summarize this formula, that the R vector or modulus of A plus B is nothing but under root of modulus of A square plus modulus of B square plus 2 into modulus of A, modulus of B, and cosine of the angle between them. So this will be our formula for finding modulus of A plus B. So we can summarize our finding as the resultant vector of A and D is modulus of A square plus modulus of B square plus 2 into modulus of A, modulus of B, cosine of the angle between them, and a root over that. So this is our magnitude of A plus B. Having said that, we still have to find the direction of this A plus B, because it's a vector and must have a specific direction. In order to find the direction of A and B, A plus B, we must look at the diagram. And we have to find the direction of this. So the direction of this vector will be given by, let's give the direction with A vector. If A vector is well defined, we can give the direction of R vector with respect to A. Let's call this angle alpha. Then in this right angle triangle you can see that tan alpha is Cp divided by OP. We can say that tan alpha is nothing but Cp divided by OP. And you have already know here that Cp is modulus of B sin theta and OP is OQ plus QP, which is modulus of A plus modulus of B cos theta. Here you can see Cp is B sin theta and OP is modulus of A plus modulus of B cos theta. So we can clearly substitute here and write this is equal to modulus of B sin theta divided by modulus of A plus modulus of B cos theta. So we can say that tan alpha is equal to B sin theta divided by A plus B cos theta, where AB represents the magnitude of A and B. And this is the angle made by the resultant vector with A vector. That also you have to remember. So let's summarize this result with our standard formula here. We can say angle made by R vector, which is nothing but A vector plus B vector, with A vector is given by tan alpha is equal to B sin theta, or modulus of B sin theta, divided by modulus of A plus modulus of B cos theta. These are the two formulas that you have to remember if you want to add two vectors graphically. And you don't have to always drop the perpendicular, calculate the length. All you can do is directly use the formula for the resultant of two vectors as modulus of R, and the angle made by the R vector with A as tan alpha is equal to modulus of B sin theta divided by modulus of A plus B cos theta. So, in order to remember the result, you also have to in order to remember these results, you also have to know their physical meaning. So R vector is A plus B, is the length of the A plus B vector if they make angle theta. So here in this formula you should know what angle theta is. It is the angle between A and B. And in this formula you should also know what is alpha. Alpha is made by the angle made by the resultant vector with A vector. Here you can see. Then only you can interpret it graphically. The result of parallelogram law of vector addition can also be summarized in terms of triangle law for vector addition. And the result can be given like this. So if in any triangle, let's say, this triangle, we have this as vector A, and suppose this is vector B, then addition of A and B, this will represent this vector here, which is start from this point to the final point is A plus B. This is the triangle law for vector addition. The rule is very simple. Suppose you are adding A and B, you start from a point, you go in the direction of A, and where the head of the A ends, you start with the tail of vector B and reach to a distance proportional to the length of B in the same direction, in the direction of D. Then this will be your final point. So you started with vector A, added vector B, you reached a point, then the vector joining initial to final point is A plus B vector. And the formula is modulus of A plus B is same as this formula here. And the angle made by this vector, A plus B vector, is alpha with A vector, and same formula is valid. Where angle theta is nothing but angle between A and B, and from this you can see the angle between A and B is not this angle, but if you join the tails of two vectors, for that you have to move A vector in the direction of A vector little forward and join their tail, then you will see the angle between them is this. So this is the angle theta in the formula. So this can also be, the result could also be summarized in terms of a triangle. This is your R vector, which is modulus of A plus B. Is same as modulus of A plus B is modulus of A square, modulus of B square, plus 2 into modulus of A, modulus of B, cos theta. Everything under square root. And angle alpha, tan alpha is given by, we have already derived this formula, so we need not go into the derivation again. And the formula is, is equal to b sin theta divided by modulus of a plus modulus of b cos theta. So vectors could be added in similar fashion to represent them graphically. Suppose we have this vector as a vector, and this vector is b vector, this vector is c vector, and this vector is d vector. And suppose we are interested in finding the resultant as sum of all these vectors, a plus b plus c plus d. Then we can use same iteration. We can add a and b first. Then to the resultant of a and b, we can add c. And then with the resultant of a plus b and c, we can add d. So we can use three triangles to find resultant R. Or we can also represent them graphically. So we go in the direction of A. So suppose we start from a point, go in the direction of A, where A ends, go in the direction of B, then where B ends, go in the direction of C, and where C ends, go in the direction of D. Then you reach to a final point, drawing a vector pointing towards initial and final point is the resultant of A plus B plus C plus D. Let's see how we can do that. So we'll select A vector, move it parallel to itself. So we start from basically this point. So this is our initial point. We go in the direction of A. So we will now move in the direction of B, where the head of the A ends, we will join the tail of B like this. This is B vector. Then this line joining initial point to the end of B point will represent A plus B. So let's do that as well. We'll represent it by some different color in order to understand. So we know by triangle law that this will represent A plus B. So this yellow line represents A plus B. Now we have to add vector C to A plus B. And what we can do is move vector C parallel to itself, and initial point remains same, and where the A plus B ends, we have to just add C point. Then we represent it with some other color. Then definitely we have this vector joining initial point to the sum of A plus B and C will represent A plus B plus C vector. So this yellow line, you can see, this one represents A plus B. And this vector is C vector. So added to A plus B, the C vector, and the resultant is this green line. So this green line basically represents A plus B plus C. So we represent it with A plus B plus C. Now, in order to add vector D with the sum of A plus B plus C, we again have to move vector D parallel to itself and join with where the C ends, or A plus B plus C ends, like this. And this is our D vector. Okay, this is our D vector. Then initial point, the vector joining initial point to the end of D vector will represent A plus B plus C plus D. Here is our resultant of A plus B plus C plus D. This is our final point. This is our initial point. This is our final point. So joining initial to final point will represent A plus B plus C plus D as proved. So a vector representing initial to final point will represent R vector. So this is our R vector, which is nothing but A plus B plus C plus D. This rule is known as polygon law for vector addition. So you can add vector addition. So you can add as many vectors as you want graphically, and it is being proved from the law of triangle. And this is in the direction of A, you add vector B, and this is A plus B. To A plus B, you can add C vector, and this will represent, this green line will represent A plus B plus C, and to that you have added D vector. Then joining the initial point to final point, where the D end will represent A plus B plus C plus D. So R vector is A vector plus B plus C plus D. So what does the polygon law suggest is, if all the vectors are represented as sides of a polygon, then in order to close that polygon, the final vector will represent the resultant of A plus B plus C plus D.